In this video, I'm going to do a short recap of properties of real numbers. First is closure. If something's closed, it remains in the same set. So when I say set, I'm talking about the sets of the real numbers like rational, integer, whole, natural, and irrational. So rationals are closed underneath addition for the simple fact that if I add two rationals, I still get a rational. And if I throw a fraction in there, right, 2 1/2 is still rational. So therefore rationals are closed underneath addition because they stay in the same set regardless. Even if rationals are closed underneath subtraction for the same reason. If I do two rational numbers and I subtract them, I still get rational. Even if I throw in like decimals, 3 minus 0.6, okay, 2.4, but 2.4 is still rational. So rational numbers are closed underneath those operations. But if I focus on whole numbers and the operation of subtraction, whole numbers are not closed under subtraction for this reason here. Okay, now here's two whole numbers, 3 and 2. As a reminder, whole numbers is 0 and up, okay, with no fractions. So 3 minus 2 is 1. Well, 1 is still whole. Okay, so that's really not a counterexample. But if I flip that, so here's 2 minus 3, which both of those are whole, but 2 minus 3 is -1. So that is not whole. So that would be a counterexample to the fact to say whole numbers are not closed under subtraction. And it just takes one counterexample to prove something to not have closure. But if you can't come up with a counterexample, then it's considered to be closed, as it would remain in the same set. Commutative property is where you can switch the order. You can remember that because commute means to go back and forth. So the commutative property works for only the addition and multiplication properties, because if you switch the order on either one of those, you're still going to get the same answer. So 2 plus 3 is 5, but 3 plus 2 is also 5. Same thing if I make those products. You would get 6 for either case. But as soon as I switch that to be subtraction, okay, well then you're going to get -1 and +1, which are obviously not the same. So therefore the commutative property would not work for subtraction. Same thing if I made these division symbols. And again, if I switch those orders, I'm going to get two different numbers, as that's 0.6 repeating, and then that's 1.5. Okay, so commutative property only works for addition and multiplication, and that means switch the order. Associative property means to group. So you can group them different and still get the same answer, and same as commutative property, it only works for all addition, and the key is that it has to be all addition, or all multiplication. But it's all about grouping. So associates, like a group of associates at a company, is how you can try to remember that. Means to group. So here I grouped the 2 and the 3 on the left. Here I grouped the 3 and the 4 on the right. By order of operations, here I'd have 5 plus 4, which is 9. And here I have 2 plus 7, which is also 9. If I switch those two products, then it's still going to work, because 2 times 3 is 6, and 6 times 4 is 24. And here you would have 3 times 4, which is 12, and 2 times 12 is also 24. So same as commutative property, and it has to be all multiplication or all addition. But as soon as you switch it to subtraction and division, that's not going to work. Identity means that it does not change. So just like your identity as a person, you are who you are. Nothing's going to change that. So that's how you should remember that. Now, mathematically speaking, you're going to think about, again, the two operations that we're going to stick with for all these properties is addition and subtraction. So with addition, there's one particular number that we can add to any number and not change its value, and that is 0. And for multiplication, there's a number that I can multiply by any number and not change its value, and that is 1. So 0 is what we call the additive identity, and 1 is the multiplicative identity, because it does not change the value when you add or multiply. Inverse, okay. Inverse is where you undo, okay, an operation to get back to where, undo an operation to get back to where you started, okay, or you can even get back to, comma, back to identity. So, in other words, what operation is going to always equal the identity? So when I'm talking about the additive inverse, I want to see what can I always do so that I get 1. Or sorry, since it's the additive identity, it's what can I always do to get 0, because 0 is the additive identity, and 1 is the multiplicative identity. So I'll stick with the number 3. Okay, and what you can do to always, to any number, is basically just add its opposite. All right, so opposite is the key there, and you always will get back to 0. No matter what number you pick, if you just add its opposite, remember opposite means change its sign, you will always get back to 0. So now for the multiplicative side, you would want to multiply by what we call the reciprocal, which is you flip it. So 3 times 1/3 will get you back to the identity. If you wanted to start with a normal fraction, all right, because remember 3 is like 3 over 1. If you flip it, it'd be 1/3. Now if you have a normal fraction, it's a little bit easier to even recognize. Okay, well that reciprocal would be 2/3, which then would be, if we multiply the tops and the bottoms, we get 6 over 6. Well, that is 1, which is your identity. So inverse, the additive inverse is opposite, and multiplicative inverse is reciprocal. And that is what will get you back to the identity. Last but not least is the distributive property, which is basically if you have a monomial in front of a set of parentheses where inside the parentheses you have at least 2 terms or more. Now, a monomial can be a number by itself, it could be a variable by itself, or it could be a product of the two. It does not matter. But in here, in order for you to have the distributive property, you have to have at least 2 terms. So maybe like 3x plus 2 for that one. Here maybe 2x squared plus 3x minus 4, so there's 3. Right here we have 5x squared minus 6x plus 3. With the distributive property, is where you have a number in front of a parentheses, and it must be multiplied to however many terms there are in the inside. And when we multiply, you got to make sure you multiply the numbers and add exponents. So for here, 3 times 3x, okay, come over here, it would be 9x plus 6, because 3 times 2, okay? And then here would be adding exponents. So x times 2x squared would be 2x cubed, because you have to add the exponents. Then 3x squared, notice that it's positive. Here, it's not positive, it is negative, because x times -4, or positive times a negative, is a negative. Okay, and then here, last but not least, 2 times 5 is 10, x times x is x squared is x cubed. All right, here, 2x times a -6x is a -12 x squared. And then positive times positive is positive. 2 times 3 is 6, and then you have the x. So it has to be multiplied through everything on the inside in order for you to distribute.